Swayam Prabha. Digital India. Educated India.
Hello everyone, this is Ram Seshan. I'll be taking you through the course on applied natural language processing for the next 12 weeks. I think you would be really interested to know what are the real requirements, the basic requirements for this course. If you know some computer science, probability and statistics at 101 level, linear algebra at the same level, and some machine learning, it will really help. And if you have lots of common sense, it's going to be really useful. If you are really interested in this subject, you can learn anything along the way. You don't need to really know the entire computer science or probability or statistics. You will definitely learn them along the way during this course. I'll also be teaching some of the fundamentals which are required for this course as we move along. All right. Okay. So let me start with what is the goal of this course. Okay. The goal of this course, as given in this slide, is the ability to process and harness information from a large corpus of text with very little manual intervention. Okay, it's a long goal, and it's a very interesting topic to deal with, because natural language processing is always about the human intelligence, right? So when we speak to someone, the other person on the other end really understands what you are speaking, if he understands your language, and then tries to respond. And so it is an intellectual way of communicating to different humans, right? So we want to be able to make the machine do the same job. Is it possible for the machine to really understand what we speak, what we write, and what is available as part of the large corpus of text that we are going to be providing it? Will it be able to understand the meaning of every word? Will it be able to understand the sentence? Will it be able to understand the context in which we are speaking? All that. So this is going to be a very long drawn journey in order to make the machine really understand everything that we do in the natural language processing, right? There is a why to it, there is a what to it, and there is also an how to it, right? So why is about why do we want to do this, and then what is it, what are we doing to make the machine understand this, and then for us to make the machine do something, we also need to provide how you should proceed in certain fashion, right? So we will be answering all these three questions at certain level during the course. So is it really hard? Natural language processing, is it really hard? So we need to really ask this question to a toddler who doesn't know any language, right? But unfortunately the toddler won't be able to communicate back to you, because he or she doesn't know what we are asking. But the way they learn quickly the language, from the parents is an amazing one, right? But unfortunately we don't know how we really learn those languages when we were very small. Okay, so leave that apart. When you talk about any of the topic or any subject, there are multiple ways of representing the same thing in one sentence, right? So we are so innovative in a way that we create sentences every time, and which are new and so on. We include a lot of common sense and contextual representation as we speak. For example, we would have seen one accident or some incident yesterday, and then when you're talking to your friend today about that, you will not be again taking the entire context into this and then start talking right from the beginning. So you start from somewhere. So both understand what we are talking about and we move on from there, right? We represent the information in a very complex way using some hard vocabulary and so on. We mix some visual clues. We use hand symbols to communicate few things, without really saying in certain words. Ambiguous in nature, since these languages are created by humans, the way you represent, the way you talk, there could be some ambiguity in it. So we somehow manage to understand even if there is some ambiguity in what we are speaking, right. Idioms, metaphors and sarcasm make it hard, especially for the machine to understand those, right. So how do you make the machine understand that there is a sarcasm in what you are saying, correct. And then the interpretation depends on the real world common sense and contextual knowledge. So all those kinds of meta knowledge that we have, we need to somehow feed into the machine in order for the machine to really take on this job, right. So it's kind of very complex mechanism in order for us to really represent that in certain algorithmic fashion. So if you are able to really represent what we do using our language in an algorithmic fashion, then it's going to be easy for us to make the machine do what we do automatically. So what are the typical tasks that we perform? I'm sure you all know about this because we have been using search engine right from the time we started using our mobile phones or computers, right. Information retrieval, find the document that we are looking for based on certain keywords. And then there is another task that we do which is called information extraction. Identify and extract personal name, date, name of the city, and then say certain other insightful information that we want to extract from documents. We just provide the keywords, for example, find which country this particular player belongs to, right. So when you provide that information as a set of keywords, you get some Wikipedia results or some portal that provides you the details of what you are looking for. The next one is language generation. This is something that you might be using on a regular basis. For example, if you are using a mobile phone and then texting it to someone, right, the keyword starts appearing as you start typing, right. When you start typing the first word or when you start typing few characters at the keyboard, you see certain predictions or suggestions, right. And then once you type a keyword and then once you type one word or keyword or whatever in the search box or in the normal text box, you see another prediction depending on what you have typed earlier, right. Again, there is some kind of a suggestion that you see. So that is something called as the language generation. We will also talk about that. And then there is another task that is performed which will automatically classify documents into groups. Supposing if there are about 10 groups in the documents that you have captured, text clustering will classify them into 10 different buckets on its own without really naming them. This is an automatic way of classification. It only uses what is there inside the document, and then depending on the keyword combination, it will start putting document A in bucket A and then document B in bucket B and so on and so forth. And the another one is text classification. This is something that you say, okay, classify these documents based on these types of keywords. If these types of keywords occur together, then it belongs to, let us say, physics document. If these keywords occur together, then it could be a spam email and so on. And the next one is the machine translation, is very, very interesting. This is about translation of one language to the other. So for us to do that, the machine should be able to understand both languages. So how do you make the machine understand this is part of the NLP task. I am sure some of you also would be using grammar checkers, as in when you type certain sentences in the text box, grammar checker automatically would start finding spelling mistakes and then maybe some syntax corrections. Will provide you some syntax corrections in the sentences that you are typing. Okay. So, these are at a very high level the typical task that we would be looking at. So, what I am going to be doing is I am going to be taking you through the 12 weeks in the next few minutes, right. Whatever I am going to be doing in the next 12 weeks, I will be giving a gist of that in the next few minutes, and then we will also see how all of these are connected, and then the answer for why we are doing this would come into then the answer for why we are doing this would be very clear at the end of this. Okay. So, before that, we will start looking at what kinds of things that we can do with the text that we have in hand. So, before that, let me first describe what this corpus is. So, corpus is nothing but a collection of documents. For example, you have been studying for certain topics, let us say operating systems in computer science. You start collecting various information related to chapter from the web, some research papers and so on. So, at the end of the course, you might be having about 100 or 150 documents that you have in hand. So, that collection is called as a corpus. You can name that corpus as an operating system corpus. So, that contains the relevant information related to certain topic. So, in this natural language processing application, we will always be dealing with certain corpus. We require large collection of documents in order for us to deal with certain applications. Okay. So, that is about the corpus. Okay. What else I can do with that corpus? So, when you are given a text for the first time, what you will start looking at, right. So, when you start looking at that, you will say, okay, I am seeing a lot of keywords, and then you will start underlining certain new words, and then you will start underlining certain words that you do not understand or do not know the meaning of that. You will start underlining some important sentences as the next step and so on, right. So, we start looking at information from a very high level and then slowly start getting into a deeper and deeper level, and at the end of that you would know what the document is all about, right. So, the same thing that we are going to be doing in the entire course. So, we are going to be looking at the documents at a very high level to begin with, and then start looking at it at a deeper level as we go further down the course. So, for all of us to do certain operations on that corpus, we require certain tools and techniques, right. So, first thing what we do is we will just look at the documents from a very high level, okay. And since we are talking about the corpus, so it is going to be having lots of words in the corpus, right. So, that is first thing that we want to look at. Okay, it contains about 1 billion words, it contains 500 million words, it contains about 50,000 vocabulary. Rest of the words are all repeated or repetitions of the vocabulary. And certain words are useful in connecting these sentences, but not really useful in terms of understanding the content of the documents. For example, the, of, in, we call them as stop words, and we say, okay, they are not going to be really providing me some good information related to the content. So, I can probably remove them. We call them as stop words. We will go through that one by one, in this. Okay, so, first what we do is we start identifying the paragraphs and sentences in the document. The second one that we look at is, okay, so how many words are in the paragraph? Okay, we call them as tokens here, right. So, how many tokens are there? The tokens are nothing but words separated by space, and then we start counting the number of tokens. So, how many words are found in the corpus. We start looking at the frequency of the terms. For example, in this particular slide, how many times tokens the word token has appeared. So, that is called the frequency of that. That is the number of tokens or words. So, in this slide we have about we have 3. So, in this slide tokens had appeared 3 times. So, in the entire collection of my 12 weeks PowerPoint presentation or PDF, this word has occurred at least 300 times. Okay, so, that is something that we start counting at a very high level without really knowing what the meaning is, right. So, we just start counting the words. So, that is where we start looking at the frequency of word, and then we start looking at the vocabulary count. Vocabulary count is nothing but the set of words, right. So, you just take the set of all the words that you have, it will give you only the unique words that it found in the entire corpus. So, most of the time the vocabulary for a very large corpus would be around 50K. Okay. And then find patterns of the words. So, how many times certain words occur together? So, how many times there are 2 words that occur always together, 3 words that always occur together. So, that is something that we want to look at. So, we will just look at, okay, this particular pattern occurs few times in this document. So, as I mentioned, we look at the term frequency, and then we also look at based on the vocabulary and the total number of words in the document, we try to find out what could be the type token ratio. Is it going to be it is going to be the same for all corpus, or it is going to be very different. So, there are certain empirical formula that we start looking at by just doing the statistical counting of all the words, and then we start looking at how many times this particular word had occurred in the entire corpus. So, we use some ratio to figure out this inverse document frequency. We will talk about that in later in the next session and so on. And then there are other empirical formulas or hypotheses that are available. They are called Ziff and Mandelbrot. So, Ziff tells the term frequency is proportional to the rank. For example, when you start ranking them in terms of the frequency, right, the highest frequency will be, let us say, start with 0, the will have the highest frequency. This is most commonly occurring word, right, and then 1 which will be, let us say, off, and so on. Okay. So, what Ziff does is it tries to find out the relationship between the term frequency and the rank. Mandelbrot also is very similar to what Ziff does, and then we also try to figure out what are the co-occurrences of word. That means, how, as I mentioned earlier, in terms of the patterns, we try to find out, okay, these 2 words always occur together. For example, you will find the words New York, right. So, you can find in the entire corpus how many times these 2 words occur together. So, since we are blindly doing it, we do not know what exactly the meaning of all those, we are just making the count of that. So, this is the very high level task that we do when a corpus is given to you, right. So, this is the first step. Any if you give any document, the first and the foremost thing that we do is do the counting without really knowing what the contents are and so on, and we look at the number of tokens, we look at the vocabulary, we try to compute the term frequency or IDF, or we also do a combination of term frequency, IDF, and so on and so forth. That is the first task that we do. Second one is, we need to go a little deeper into those documents. It is not enough that we if we just find it's not enough if we just find the frequency or term frequency or making those counts and then trying to figure out those ratios and so on. We still want to get something out of the document, right. So, what all things that we can do? So, that is where probability comes into the picture. So, we will talk about this a little detail with respect to the document, not with respect to the coins. Okay. I am going to be giving a very high level reason on why we are looking at probability in the natural language processing. So, it actually provides methods to predict or make decisions based on what we have counted, right. So, you can, so for example, I have counted the terms New York, right. So, they occur always together, the co-occurrence of those two words. So, next time when I give a word new to the system, and if New York occurred so many times than new and any other word, the system will be able to predict that the next word for the new would be New York. So, that is where probability comes into the picture. Okay. So, we can make the informed decision based on the data that is available to us, based on the history that we have captured, right. So, this is what we can do with probability. So, we can make some informed decision, right. So, we can also get the quantitative description or chances or likelihood associated with various outcomes. We can look at the probability of a sentence. For example, assume that I have looked at the entire corpus, made all the statistical counting and so on and so forth, right. And then I am just giving a new sentence which consists of, let us say, 4 words. So, what is the probability of this sentence being part of the corpus is something that we can deal with if we know the entire details of the corpus, and we have counted all the terms and frequencies, we have counted the co-occurrences of words and so on, right. So, given a new sentence, so we would be able to get the probability score for that particular sentence, whether it is a very high probable sentence according to the corpus, or it is not possible to have such a sentence based on the corpus that we have in hand. So, that is something we will be talking about. As I mentioned earlier, probability of the next word in this sentence, how likely to predict you as the next word. So, let us say I am going to be typing okay. So, when I type this word wish, how likely we are going to be finding the you as the next word. So, we will be bringing in the conditional probability. The probability of this word coming in after wish is so much, there is some number that will come along with that, and there could be several combinations or several words also that could be coming after wish, right. So, based on which one has the higher value, that particular word would be picked up as the next word. So, this is something that we already spoke about. So, we will be talking about discrete sample space, the kind of experiment we do, joint and conditional probabilities and so on. Okay. So, we will talk about this during the course, and then how really we use all these in the natural language processing. So, we will also look at as I mentioned earlier, how we can compute the probability of a sequence of words. A sentence is nothing but a sequence of words, right. So, if you are given 3 or 4 words or 10 words strung together to form a sentence, what is the likelihood of that particular string of words could be a legal sentence. So, that is something that we can compute using the language model, and we will talk about this in detail in one of the weeks. Okay. So, see where we are going, right. So, initially we just looked at only the words without really looking at the meaning of any of those. And then next we started looking at the statistical counting that we have in hand, and then use the probability to start predicting what could be the next word, whether the sentence that I am going to be creating is really possible to have as the sentence that I am going to be creating is going to be really probable, or is what is the likelihood of that particular set of words to form as a sentence, and so on, right. So, those are things that we are going to be doing as the next step. So, based on the counting that we had done earlier, so now we have moved up further to figure out a few things using the probability, right. So, that is the second step, keep remembering that. First counting, second we are just trying to make some sense out of the historical information that we have gathered using the numbers, and third we are going to be looking at the sequence of words and then try to figure out whether that particular sentence could be a legal sentence or not based on what history that we have captured, right. So, that is the third one.